So in this video, I will integrate using U-Substitution, and this will be a harder example, and this will be example one. So the direction says integrate from 0 to 1 of x squared times 2 raised to the x cubed dx. So I know what you're thinking, why can't we just use u as x cubed, right? Sure, we'll try. Let's see. Let's use blue. So let's try it. If u equals to x to the third, then du would be 3x squared dx. It looks okay for like, it would be 0 to 1, and then it would be 2 raised to the u, and then we have x, and then all we have to do is get rid of this 1/3. I mean, get rid of this 3 by multiplying by both sides by 1/3. So that would be 1/3 du equals to x squared dx, right? Yeah, it looks good. But the thing is, and then you would take out this 1/3, and then be 2u du. The only problem is we don't know what the integral of 2 raised to the u is, right? We know that the integral of e to the x is e to the x. We don't know this. So we're going to have to do something else. We're going to have to use what we know. So yeah, like we said before, we know that the integral of e to the x dx equals to ex plus c, right? So how can I rewrite 2 as a base, something with the base with e to the x? Well, I know that 2 can equal to e raised to the ln of 2, right? I'm trying to rewrite 2 as a base of e, right? Because yeah, I know that the base of 2 is the same thing as e raised to the ln of 2, right? Because the e and the ln cancels and you're left with 2. But we want 2 raised to the x cubed, so 2 raised to the x cubed is, now what's the rule form raising? You multiply the exponents, right? So it's going to be e to the ln of 2, raise it to the x3. Okay, so you could rewrite 2 to the x cubed, or 2 raised to the x cubed is equal to, so when you raise, you multiply, so you can rewrite this as e to the x cubed ln of 2. Okay, so let's do that. So it's going to be 0 to 1, and then it's going to be x squared, and then we're going to rewrite 2 to the x cubed as e to the x ln of 2, right? Okay, so that's what I did. So all I did was I rewrote 2 to the x cubed as e raised to the x cubed ln of 2. Okay, now can we try U-Substitution? Yes. So let's use our new u would be ex cubed ln of 2, right? So our new u would be x cubed ln of 2. Then you take the du, or the derivative u. So what is the derivative of x cubed ln of 2? Well, ln 2 is a constant. So a constant times x cubed. So you could just ignore the ln 2, just take the derivative of x cubed. So just bring down ln 2, and then take the derivative of x cubed, which is 3x squared, and then don't forget your dx. Okay, if you want, what we can do is, Right, okay, so we have du equals ln of 2 times 3x squared dx. Or if, yeah, if you want, uh, you can rewrite this as 3 ln of 2 times x squared dx. Okay, so all I did was I put the 3 in front. So this is the same thing as this. Is there anything else you could do with your properties of log and natural log? Yes, right? So right here, when we have a 3 ln of 2, remember if you have a number in front of the natural log or even just regular log, when you expand it, it's a power, right? So you can rewrite 3 ln of 2 as ln of 2 to the third times x squared times it by dx. Okay, so then ln of 2 to the third is the same thing as ln of 8 times x squared dx. Okay, so is there anything we need to get rid of? Yes, we need to get rid of this ln of 8. So how do I get rid of this ln of 8, or that constant? Is you multiply by the reciprocal of ln of 8. So that would be 1 over ln of 8 on both sides. Okay, so on the left, it's 1 over ln of 8 du. And then on the right, the ln of 8 cancels, and then you're just left with x squared dx. Okay, so now we can rewrite this. Wait, we should change the boundaries, right? We're going from 0 to 1. So let's change our boundaries real quick. It'll make your life easier. So if we said that u was x cubed ln of 2, and one of our x is 0, so it's going to be u equals 0 to the third times ln of 2. That means u equals to 0. And then what's our other u? It would be ln of 1 to the third ln of 2. So it would be 1 to the third is 1 times ln of 2, that's ln of 2. Okay, so we can rewrite this problem. We could change our boundaries to 0 and ln of 2. Then it's going to be e to the u, because our u is x cubed ln of 2, times, you can replace x squared times dx with 1 over ln of 8 du. Okay, I'm going to put it here. I need more space. So do you see this 1 over ln of 8? That is a constant, so you could put it outside the integral. So it'd be 1 over ln of 8. And then it's 0 ln of 2. And then it's going to be e to the u du. Okay, so what is the integral of e to the u? It's just e to the u. And then remember, we still have to bring this 1 over 8, 1 over ln of 8. Then you could do your boundaries. So our new boundary is 0 to ln of 2. Okay, so this would be e to the ln of 2, and then it's still 1 over ln of 8 minus e to the 0, 1 over ln of 8. Okay, so on this side here, e to the ln are inverses, so it cancels. So you're just left with 2 and times 1, so that's 2 over ln of 8 minus e to the 0 is just 1, and then still over ln of 8. Okay, 2 minus 1 is 1 over ln of 8. That is your final answer. Okay, so this was a harder example of U-substitution because we kind of had to change the base. We had to change 2 to the x cubed in base of e to the x. Okay, go ahead and copy or in pause or this, yeah, this, we could stop here.